Good day and welcome to recording 1F in our series on trigonometric ratios of any angle for Unit 2, Chapter 2, Trigonometry, Mathematics 2200. We'll be looking at how to find angle measures given an exact or approximate trigonometric value. Step 1 in the process will be to determine which quadrants the solutions will be in by looking at whether the ratio that we're given is positive or negative. That's where CAST will be handy. We solve then for the reference angle, and we sketch the reference angle in the appropriate quadrant and use it to help us determine the angle of rotation we are really looking for. Also useful is the ability to recognize these exact trigonometric ratios for cosine, sine, and tan of 30, 60, and 45. Example 1. Determining angle measures given an exact trigonometric value, no calculator permitted. We're told that the cosine of an angle is equal to negative root 3 over 2. We've got to find all possible measures of that angle where that angle lies between 0 and 360 degrees. Step 1 in our process says locate the possible locations of the terminal arm. So we'll do that. By CAST, we could be in either quadrant number 2 or in quadrant number 3. Now that negative root 3 over 2 looks like it could be based on our special triangle. This is where the reference angle comes in. Our special triangle has, if you permit me to fix that little vertical line there, that's better. A 30, 60, 90 triangle has sides of 1, root 3, and 2, located like so. We note that the cosine of 30 degrees is root 3 over 2, so therefore our reference angle must be 30 degrees. Cosine of 30 degrees is root 3 over 2, so we use that to help us figure out the reference angle. So we have a 30-degree reference for each of these angles from standard position. So rotating from the positive x-axis to the second quadrant, our first possible value of theta in quadrant 2. Theta is equal to 180 minus the reference. So in this case, that's 180 minus the 30, which gives us 150 degrees. For quadrant 3, let's work on that one. Theta is equal to, well, it rotates past the 180 degree line. So we've got theta equals 180 plus the reference. I'll have to continue across here because of space limitations. 180 plus 30, which is 210 degrees. In this next example, we're given an approximate value of cosine, and therefore we're going to need to use a calculator at some point. We start off the same way as the last problem. We used the sine, in this case negative value of cosine, to determine possible locations for the terminal arm. That's quadrants 2 and 3 again. And we are asked to find the possible values of theta to the nearest tenth of a degree, and the values of theta have to be between 0 and 360. Now, we don't just plug in the negative decimal 6753 and do inverse cosine on our calculator, because that's not reliable for reasons beyond the scope of this course. So we find instead the corresponding first quadrant reference angle. So I'll do a quick sketch here, X and Y axes, and the first quadrant reference angle is what we're looking for. In the first quadrant, everything is positive, so the cosine of theta sub r must therefore be .6753, not negative. So cosine theta sub r equals .6753. Use your calculator. Theta sub r is equal to inverse cosine of .6753. That works out to be approximately 47.5 degrees. Therefore, in quadrant number 2, we have a value of theta there with a reference of 47.5. So we've got quadrant 2 angle. Theta equals 180 minus the 47.5 degree angle. That gives us 132.5 degrees. And in quadrant number 3, we have an angle that rotates all the way over past the 180 line. Still has a reference though of 47.5. So theta there is equal to 180 plus 47.5 degrees, which is 227.5 degrees. To conclude and summarize, be able to recognize the trigonometric ratios based on our special triangles, and they will help you to recognize reference angles for exact trigonometric values. And whether working with exact or approximate trigonometric values, here are the 3 basic steps.